Hi students, welcome to the 7th lecture in permutations and combinations. I hope you have watched the first 6 lectures. So in the first 6 lectures we have discussed about permutations when repetitions are not allowed. In this lecture we are going to discuss about permutations when repetitions are allowed. When repetitions are not allowed, we have this formula. The number of permutations of n distinct objects taken r at a time is npr is equal to n factorial upon n minus r factorial. When repetitions are not allowed, we will not mention it. When repetitions are allowed, we will definitely mention it. So if in a problem, if they don't mention anything, then you have to assume that the problem is based on permutations when repetitions are not allowed. If repetitions are allowed, we are going to mention it. Okay. Now, let us look at this first result. If n comma r are positive integers, then the number of permutations of n distinct objects taken r at a time when repetitions are allowed is n raised to r. So in the textbook they have given the proof based on mathematical induction, but here I am not going to use mathematical induction. I am going to use fundamental principle of counting. So what is given here? N distinct objects. So we have to find number of permutations of n distinct objects taken r at a time. 1, 2, 3, so on up to r. Now I can fill these r blanks using these n objects. So our task is to fill these r blanks. Fill these r blanks with n objects. Now here what I am doing is I am dividing this task into r works. The first work is to fill the first blank, and the second work is to fill the second blank, and the third work is to fill the third blank, and so on up to WR. Now the number of ways of doing W1. The number of ways of doing W1 in the sense the number of ways of filling the first blank. So let me write down what is W1, W2 and so on. WI stands for filling the rth blank or filling the ith blank. Now we can do W1 in number of ways of doing W1 is equal to n. Why number of ways of doing W1 is equal to n? We have n distinct objects, and using those n distinct objects I can fill the first blank in n ways. I can fill this first blank in n ways. After filling the first blank in n ways, I will be again left with these n objects because repetitions are allowed. I repeat, after filling the first blank with any of these n objects, I will be again left with n objects to fill the second blank. Therefore, number of ways of doing W2. Number of ways of doing W1 is equal to n, number of ways of doing W2 is equal to n, and so on. Number of ways of doing WR is also equal to n. Therefore, the total number of ways of completing the task is equal to number of ways of doing W1 times number of ways of doing W2 and so on up to number of ways of doing WR, which is equal to n times so on up to n r times. So which is equal to n raised to r. So these are the total number of permutations of n distinct objects taken r at a time when repetitions are allowed. So definitely this number is going to be more than NPR. So you can look at the statement of the theorem once again. So here there are no constraints on n and r. There are no constraints on n and r. The only constraint that we have is n and r are positive integers. When repetitions are not allowed, there is a constraint on r should be less than or equal to n. But here there is no restriction on n and r. Okay. The number of permutations of n distinct objects taken r at a time is going to be n power r when repetitions are allowed. Next we have this result. The number of permutations of n distinct objects taken r at a time with at least one repetition is going to be n raised to r minus npr. So number of permutations of n distinct objects taken r at a time with at least one repetition is going to be n raised to r minus npr. So why we have this result is n raised to r stands for the number of permutations of n distinct objects taken r at a time when repetitions are not allowed. When repetitions are allowed. And npr stands for number of permutations of n distinct objects taken r at a time when repetitions are not allowed. So if I subtract this from this one, I am going to eliminate all the permutations without repetitions. Eliminating all the permutations without repetition is same as finding the number of permutations with at least one repetition. N raised to r minus npr gives the number of permutations of n distinct objects taken r at a time with at least one repetition. So without repetition, this is our number npr. With repetition, we have n raised to r. So with repetition in the sense you can repeat any number of times. Now with at least one repetition is going to be n raised to r minus npr. The total number of permutations minus the number of permutations when repetitions are not allowed. Okay. Anyway, this is an easy result. You can just see it. Next we have this following definition about palindrome. A word or a number is said to be palindrome if it reads the same from left to right or from right to left. And a few examples are ATTA ATA and ROTOR rotor and 1 2 3 2 1 and so on. So if you are familiar with Telugu language, then you can have this one Jalaja and Vikata Kavi. So these words when read from left to right and when read from right to left will give the same meaning. So these kind of words are, these kind of numbers are called as palindromes. Now we have to count how many palindromes we can form using n distinct objects of length r. The number of palindromes of n distinct objects of length r is going to be n raised to r upon 2 when r is an even number. When r is an odd number, then the result is going to be n raised to r plus 1 upon 2. You can easily visualize this result. So if I want to form a 4-digit palindrome, then it is enough to fill the first two blanks. If the first two blanks are x and y, then I can fill the remaining two blanks. And the third place is going to be y and the fourth place is going to be x. So if I want to if I want to write a 4-digit palindrome, it is enough to mention the first two places. If I want to mention, this is about 4 digits. So if I want to write a 6-digit palindrome, I have to fill these 3 blanks. If I fill these 3 blanks, then automatically the remaining 3 blanks are filled. So if these 3 blanks are filled with x, y and z, then automatically these blanks will be occupied by z, y and x. So in order to form a 4-digit palindrome, it is enough to fill the first two blanks. In order to form a 6-digit palindrome, it is enough to fill the first 3 blanks. Similarly, if I want to form an r-digit palindrome where r is an even number, then it is enough to fill the first r upon 2 places. And the first r upon 2 places can be filled in n raised to r upon 2. Therefore, the number of palindromes of length r when r is an even number is going to be n raised to r upon 2. Now, if I want to form a 3-digit palindrome, so the 3-digit palindrome will be like this: x, y and x. This is a typical example of a 3-digit palindrome. So in order to form a 3-digit palindrome, I have to fill the first 2 places. I have to fill the first two places. If I fill the first two places, then automatically the third place will be filled. Similarly, if I want to form a 5-digit palindrome, then I have to fill the first three places. This is X, Y, and Z, and the remaining letter will be Y and Z. So, in order to form an odd-digit palindrome, we have to fill the first R plus 1 upon 2 places. So, here I have to fill the first two places. That means 3 plus 1 upon 2. So, I have to fill the first two places. So, in order to form a 5-digit palindrome, I have to fill the first three places. If I want to form a 7-digit palindrome, then I have to fill the first 4 places. So if I want to form an odd-digit palindrome where R is an odd number, then I have to fill the first R plus 1 upon 2 places. These R plus 1 upon 2 places can be filled in n raised to R plus 1 upon 2 ways. Therefore, the total number of palindromes is going to be n raised to R upon 2 when R is an even number, and n raised to R plus 1 upon 2 when R is an odd number. Now we have a few examples related to permutations when repetitions are allowed. So with this we have finished all the concepts related to permutations when repetitions are allowed. So we have problems based on palindromes and we have problems based on the result n raised to R. The first example problem is like this. Find the permutations of 4 digits that can be formed using the digits 1, 2, 3, 4, 5, 6 when repetitions are allowed. So whenever we have the notion of repetitions allowed, they will mention it. If they haven't mentioned it, you have to assume that the repetitions are not allowed. So here they have clearly mentioned that the repetitions are allowed. So we have to use the formulas related to permutations when repetitions are allowed. So what is the solution for this one? Number of permutations of n distinct objects taken R at a time when repetitions are allowed is n raised to R. N raised to R when repetitions are allowed. So here n is equal to 6 and R is equal to 4. Therefore the answer is 6 raised to 4. So we have to form a 4-letter word or 4-digit number. So 1, 2, 3, 4. So we have 6 objects or 6 numbers. I can fill the first place with any of these 6 numbers. I can fill the second second place also with any of these 6 numbers because repetitions are allowed. When repetitions are allowed, we will not exhaust the objects. So I can use the same object in second place, third place and fourth place. So the number of options to fill the first place is equal to 6 and the number of options to fill the second place is again 6 and the number of options to fill the third place is 6 and fourth place is also 6. Therefore on the whole, the number of ways of number of 4-letter or 4-digit numbers is equal to 6 raised to 4. And the second question is like this. Find the number of 4-letter words that can be formed using the letters of the word piston with at least one letter repeated. So here they are asking us to find the number of 4-letter words with at least one letter repeated. So what is the formula that we have? N raised to R minus NPR. N raised to R gives the total number of permutations when repetitions are allowed. And NPR gives the total number of permutations when repetitions are not allowed. Therefore, N raised to R minus NPR gives the total number of permutations with when with at least one letter repeated. So here N is equal to piston, Piston, consists of 6 letters and R is equal to 4 because we have to form 4-letter words. Therefore, the total number of permutations with at least one repetition is 6 raised to 4 minus 6p4. Okay, The next problem is like this. A number lock has 3 rings and each ring has 9 numbers 1, 2, 3, so on up to 9. Find the number of unsuccessful attempts that can be made by a man who tries to open the lock without knowing the key. So we have a number lock which consists of 3 rings and each ring has 9 numbers. Therefore, the total number of ways in which we can set the key is equal to the number of ways to set the key is equal to 9 cube. Okay. Now, before answering this question, so I think you are familiar with cricket. So if a batsman plays 20 balls and on the 20th ball he gives a return catch to the bowler. Now the question is, how many balls he have faced successfully? The number of balls that he have faced successfully is going to be 20 minus 1, which is 19, because he have faced the first 19 balls successfully and on the 20th ball he failed. Okay, so here also the same concept is applicable. Now you are trying to open the lock without knowing the key. So if you open the key in the first attempt, then the number of unsuccessful attempts is going to be 0. If you open the lock in the second attempt, then the number of unsuccessful attempts is going to be 1. So here the question is the maximum number of unsuccessful attempts that can be made by a person who tries to open the lock without knowing the key. So the number of ways in which we can set the key is equal to 9 cube. Therefore, the total number of unsuccessful attempts, maximum number of unsuccessful, okay. If the person succeeds, the person opens the key, opens the lock in the first attempt, then the number of unsuccessful attempts is going to be 0. If he opens the lock in the second attempt, then the number of unsuccessful attempts is going to be 1. So here they are asking us to find the maximum number of unsuccessful attempts. So if he opens the lock in the last attempt, in the sense in the 9 cubed attempt, and the number of unsuccessful attempts is going to be 9 cube minus 1. This implies the maximum number of unsuccessful attempts is equal to 9 raised to 3 minus 1. So this is the total number of this is the maximum number of unsuccessful attempts that a person can make when he tries to open the lock without knowing the key. The fourth problem is like this. Find the number of 6 and 7 letter palindromes that can be formed using the letters of the word equation. So we have to form 6 letter palindromes and we have to form 7 letter palindromes using the letters of the word equation. So first of all, equation has how many letters? EQUATION. So we have 8 letters. So n is equal to 8. We have to form 6 letter palindromes and 7 letter palindromes. And then a formula for r letter palindromes is going to be n raised to r upon 2 when r is even, and n raised to r plus 1 upon 2 when r is odd. So here we have to form 6 letter palindromes and 7 letter palindromes. So for 6 letter palindromes we have to use the first formula, and for 7 letter palindromes we have to use the second formula. So 6 letter palindromes is equal to is equal to n raised to 6 upon 2, which is equal to 8 cube. 7 letter palindromes is equal to n raised to 7 plus 1 upon 2, which is equal to 8 raised to 4. These are the total number of 6 letter palindromes and 7 letter palindromes that can be formed using the letters of the word equation. The next problem is like this. Find the number of 7-digit numbers that can be formed using the digits 0, 1, 2, 3, 4. So we have to find 7-digit numbers that can be formed using the digits 0, 1, 2, 3, 4. So we have to fill these 7 blanks. 1, 2, 3, 4, 5, 6, 7. We have to fill these 7 blanks using 0, 1, 2, 3, 4. So we have 5 numbers. I can fill the first blank using any of these things. I can fill the second blank using any of these things. Similarly, I can fill the 7th place with any of these things. But here we have this special number 0. So whenever we have 0 in the given objects, you have to be little bit careful. I cannot fill the first place with 0. Why I cannot fill the first place with 0? Because if I fill the first place with 0, then it is going to be a 6-digit number, or it is not going to be a 7-digit number. Therefore, in order to fill I can fill the first place with only 1, 2, 3 or 4. So to fill the first blank, we have, so I can divide this work into this task into 2 works, W1 and W2. W1 is to fill the first blank. So this can be done in 4 ways, 1, 2, 3, 4. And W2 is to fill the remaining blanks. And this can be done in cardinality of W2 is equal to, in order to fill each blank, we have 5 options. So we have 5 raised to 6. So total number of ways of completing the task is equal to 4 times 5 raised to 6. These are the total number of 7-digit numbers that can be formed using the digits 0, 1, 2, 3, 4. So whenever 0 comes, you have to be little bit careful in filling up the first place. The next question is like this. Find the number of 5-letter words that can be formed using the letters of the word mixture, which begins with an vowel when repetitions are allowed. Okay, so we have to find the number of 5-letter words that can be formed using the letters of the word mixture. But here the constraint is the first letter should be filled with an vowel. So first let us write down the letters of the word mixture. So M-I-X-T-U-R-E. So total we have 7 letters. So what are the vowels here? The vowels here are I, U and E. These are the 3 vowels that we have. Now we have to form 5-letter words. So 5-letter words means we have to fill these 5 blanks. 1, 2, 3, 4, 5. I can fill the first blank only with an vowel. That means I, U or E. So I can fill the first blank in 3 ways. So after filling the first blank in 3 ways, there are no constraints on the remaining blanks. So I can fill the remaining blanks with any of the given letters. So the second blank can be filled in 7 ways, and the third blank can be filled in 7 ways, and so on. The last blank also can be filled in 7 ways. Therefore, the total number of 5-letter words. So 5-letter words is equal to is equal to 3 times 7 times 7 times 7 times 7. which is equal to 3 times 7 raised to 4. So here 3 stands for the number of ways of filling the first blank, and 7 raised to 4 stands for the number of ways of filling the remaining 4 blanks. There are no constraints on the remaining 4 blanks. Therefore, I can fill the remaining 4 blanks with any of these 7 letters. If repetitions are not allowed, if I fill the first blank with one of the vowels, then I can fill the second blank with only 6 letters. That is when repetitions are not allowed. But here repetitions are allowed. Therefore, even if I use U in the first place, I can use U in the second place also. Therefore, in order to fill the second place, I will still have the 7 options. Therefore, the total number of 5-letter words that can be formed using the letters of the word mixture, which begins with an vowel when repetitions are allowed, is equal to 3 times 7 raised to 4. So, I encourage the students to write the final statement like this. The final statement is the total number of 5-letter words that can be formed using the letters of the word mixture, which begins with an vowel when repetitions are allowed, is equal to 3 times 7 raised to 4. Next, we have an interesting problem. Find the number of functions from a set A with m elements into a set B with n elements. So we can find the number of functions from a set A with m elements into a set B with n elements using these permutations. So we have this set A which contains m elements A1, A2 and so on up to am. And we have another set B which contains n elements B1, B2 and so on up to Bn. Now we have to find how many functions are possible from the set A into the set B. Okay. So for this we can just take a simple example and then we can see. Suppose we have a set A with 3 elements A, B, C and a set B with 4 elements 1, 2, 3, 4. Now I can map A to any of these 4 elements 1, 2, 3, 4. So A has 4 options, B has 4 options and C has 4 options. Our task is to find a function from A to B. Task is to find the number of functions from A to B. So this task can be divided into 3 works. W1 is to map A. And this can be done in 4 ways. And W2 is to map B. And this can be done in again 4 ways. W3 is to map C. And this can be done in 4 ways. Therefore, the total number of ways of completing the task is equal to number of ways of completing W1 times number of ways of completing W2 times number of ways of completing W3, which is equal to 4 times 4 times 4, which is equal to 4 cubed. So the number of functions from a set A with 3 elements into a set B with 4 elements is going to be 4 cubed. So here also we have the same thing. The number of functions from a set A with m elements into a set B with n elements. A1 has n options. N options in the sense A1 can be mapped to any of these n elements. Similarly, A2 can be mapped to any of the element in B. And similarly an. Therefore, the total number of functions is equal to A1 can be mapped in n ways, A2 can be mapped in n ways and so on up to n. How many n's we have? M, which is equal to n raised to m. These are the total number of functions from a set A with m elements into a set B with n elements. So you should not remember the function like this, n raised to m. You have to remember the answer like this, cardinality of b raised to cardinality of a. The total number of functions from a set A with n elements, m elements into a set B with n elements is going to be cardinality of B raised to cardinality of n. Cardinality of B means number of elements in B. Cardinality of A means number of elements in A. Okay. Now let us look into this problem. Find the number of surjections from a set A with n elements into a set B with 2 elements. So this is a special problem. So we have to find the number of surjections from a set A with n elements into a set B with 2 elements. So first let me write down the set. So we have this set A1, A2 and so on up to AN, and another set which contains only 2 elements 1 and 2. Now we have to find the number of surjections from this set A into this set B. The total number of functions from the set A into the set B is 2 raised to n. But we are not interested in the total number of functions. We are interested in only surjections. Surjections means codomain is equal to range. So if you are confused with surjections, let me give some examples so that you can get some clarity. A, B, C, X, Y, Z. A is mapped to X, B is mapped to X, C is mapped to Y. Now this is not an example of a surjection. Why this is not an example of a surjection? Because here the codomain is equal to X, Y and Z. But the range is equal to only X and Y. Here the range is not equal to codomain. Therefore this is not an example of a surjection. So by a surjection what we mean is none of the element in the codomain should be vacant. Here the element Z is vacant. So if none of the elements in the codomain is vacant, then we can say that the function is going to be a surjection. Suppose you can take this example. A, B, C, 1, 2. A is mapped to 1, B is mapped to 2 and C is mapped to 2. Now this is an example of a surjection. Now A, B, C, 1, 2. A is mapped to 1, B is mapped to 1 and C is mapped to 1. Now this is not an surjection. This is an example of a function which is not a surjection. Now we have to find the total number of surjections that are possible from a set A with n elements into a set B with 2 elements. Okay. The total number of functions is going to be total number of functions is going to be 2 raised to n. Cardinality of B raised to cardinality of A, which is equal to 2 raised to n. Now we have to see what are the functions which are not surjectives. If all the elements of the function of the set A1, A2, so on up to AN, if all the elements are mapped to 1, A1 is mapped to 1, A2 is mapped to 1, so similarly AN is also mapped to 1. Then this is not a surjection. If all the elements are mapped to 2, then also it is not a surjection. So we have two functions which are not surjections. Here we have two functions which are not surjections. The total number of functions is going to be 2 raised to n, and the number of functions which are not surjective is equal to 2. Therefore total number of surjective functions is equal to number of surjections is equal to 2 raised to n minus 2. there are only two functions which are not surjective here. So this is an example of a function which is not a surjective, and the other example is all the elements are mapped to 2. So these are the two examples where the given function is not going to be a surjective. Otherwise, every other function is going to be a surjective. Therefore, the total number of surjective functions is equal to number of functions minus these two. Number of functions is 2 raised to n, and the number of functions which are not surjective is equal to 2. Therefore, the total number of surjective functions is going to be 2 raised to n minus 2. Next, we have a problem related to divisibility. Okay. Find the number of 4 digit numbers that can be formed using the digits 1, 2, 3, 4, 5, 6, which are divisible by 2, which are divisible by 3, when repetitions are allowed. I repeat, find the number of 4-digit numbers that can be formed using the digits 1, 2, 3, 4, 5, 6, which are divisible by 2 and which are divisible by 3, when repetitions are allowed. So, you know the test of divisibility for 2. So, what is the test of divisibility for 2? The last place in the sense the units place must be filled with either 2 or 4 or 6 or 8 or 0. Or the number should be an even number. If the number is an even number, then we can say that the number is divisible by 2. And the test of divisibility for 3 is the sum of the digits must be divisible by 3. Okay. So first let us answer the first question. Number of 4-letter words that are divisible by 2. So the given digits are 1, 2, 3, 4, 5 and 6. So total we have 6 digits. Out of these 6 digits, 2, 4, 6, these are even. So 4-digit numbers divisible by 2 is equal to 1, 2, 3, 4. I have to fill the last blank with either 2 or 4 or 6. And the remaining places I can fill with any of these 5 elements, any of these 6 elements. So I can fill the first blank with any of these 6 digits, and I can fill the second blank with any of the 6 digits. I can fill the third blank with any of the 6 digits. But when I come to the 4th place, I have to fill the 4th place with only 2 or 4 or 6. Therefore, the total number of 4-digit numbers that are divisible by 2 is equal to 6 times 6 times 6 times 3, which is equal to 3 times 6 raised to 3. So these are the total number of 4-digit numbers that are divisible by 2. Now, let us answer the second part. So this second part is a little bit tricky. So here I cannot find the sum of all 4-digit numbers because I don't know what are the 4 digits. So here repetitions are going to be allowed. Okay. So here we are using a special technique, and with this special technique you can solve some of the example problems and exercise problems. And this technique is unique here. And this technique works only if the given numbers are consecutive. So here the given numbers are 1, 2, 3, 4, 5, 6. All these numbers are consecutive numbers. Now, we have to form a 4-digit number. So let us assume that the 4-digit number looks like this. So I have filled the first 3 digits with x, y and z. I can fill the first 3 digits with x, y and z. Now I have to fill the 4th place. So the 4th place can be 1, 2, 3, 4, 5 or 6. I can fill the first 3 blanks without any constraints. So I can fill the first place with any of the given 6 digits. I can fill the second place with any of the given 6 digits. I can fill the third place with any of the given 6 digits. So this place can be filled in 6 ways. This place can be filled in 6 ways. And this place can be filled in 6 ways. So I can fill the first 3 blanks in 6 raised to 3 ways. So after filling the first 3 blanks in 6 raised to 3 ways, Now I can fill the fourth blank with any of these 6 numbers, 1, 2, 3, 4, 5, 6. Okay. So xyz1, xyz2, xyz3, xyz4, xyz5 and xyz6. These are the 6 consecutive numbers. I repeat, xyz1, xyz2, xyz3, xyz4, xyz5, xyz6. These are the 6 consecutive numbers that we are going to form. So out of any 6 consecutive numbers, there are exactly 2 numbers which are divisible by 3. So let me write this statement for you. Out of any 6 consecutive numbers, only 2 are divisible by 3. So you have to remember this statement for this exercise and throughout this chapter. So this is a special technique. If you remember this technique, you can solve the problems like this. So here I don't know what is x, and here I don't know what is y, and here I don't know what is z. Therefore I cannot find the sum of these digits. So what I will do here is, I will first fill the first 3 places in any of the manner which I want. So I can fill the first 3 places in like this, x, y and z. So which can be done in 6 ways, 6 ways, 6 ways, which is 6 raised to 3 ways. So after that I can fill the last blank in only 2 ways, because out of these 6 consecutive numbers, only 2 numbers are divisible by 3. Out of any 6 consecutive numbers, only 2 numbers are divisible by 3. Therefore the last blank can be filled in 2 ways. Therefore the last place can be filled in 2 ways. So this implies required answer is 6 times 6 times 6 times 2. So this is my total number of 4-digit numbers that are divisible by 3 when repetitions are allowed. So this is a special case. Here we are not using test of divisibility of 3. Instead of using test of divisibility of 3, we are relying more on the information. The information here is the given numbers are consecutive. The given numbers are 1, 2, 3, 4, 5, 6. So first I will fill the first 3 places in whichever manner I want. After filling the first 3 places in whichever manner I want, and then I can fill the last place with 1, 2, 3, 4, 5 or 6. So if I fill the last place with these numbers, then I am going to get 6 consecutive numbers. Out of any 6 consecutive numbers, there are only 2 numbers which are divisible by 3. Okay. So if you take any 10 consecutive numbers starting from 2 to 11. So 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So out of these 10 consecutive numbers, there are only 2 numbers which are divisible by 5, namely 5 and 10. So if you take 20 consecutive numbers, there will be exactly 4 numbers which are divisible by 5. So if I take 42 consecutive numbers, there are exactly 7 numbers which are divisible by 6. If I take 90 consecutive numbers, there are exactly 10 numbers which are divisible by 9. So here also, if I take any 6 consecutive numbers, then there will be only 2 numbers which are divisible by 3. So here the 6 consecutive numbers are like this. Therefore the total number of 4-digit numbers that can be formed using the digits 1, 2, 3, 4, 5, 6 which are divisible by 3 is going to be 6 times 6 times 6 times 2. So the answer is going to be 6 raised to 3 times 2. Next we have this last example problem. Find the number of 5-digit numbers, find the number of 5-letter words that can be formed using the letters of the word explain, which begin and end with an vowel when repetitions are allowed. I repeat the question. Find the number of 5-letter words that can be formed using the letters of the word explain, which begin and end with an vowel when repetitions are allowed. So what we have to do is we have to form a 5-letter word using the letters of the word explain. E, X, P, L, A, I, N. So here the vowels are E, A, I. These are the 3 vowels that we have. And how many letters we have? E, X, P, L, A, I, N. 7 letters. Now we have to form 5-letter words. We have to form 5-letter words. 1, 2, 3, 4, 5. Now we have to fill the first blank with an vowel and the last blank with an vowel. So the task of filling these 5 blanks is divided into 3 works: W1, W2 and W3. W1 is to fill the first blank with an vowel, W2 is to fill the last blank with an vowel, and W3 is to fill the remaining blanks with any of the given letters. So I can fill the first blank with an vowel in 3 ways. And I can fill the last blank with an vowel in any of the 3 ways. So if I use an vowel A here, again I can use A in the last blank because repetitions are allowed. So here I can use 3 vowels, here also I can use 3 vowels. So the number of ways of doing W1 is going to be 3, and the number of ways of doing W2 is also going to be 3. Now the number of ways of doing W3. So here I can fill this blank in 7 ways, this blank in 7 ways, and this blank in 7 ways. Therefore, the total number of 5-letter words that can be formed using the letters of the word explain, which begin and end with an vowel, is going to be, so number of ways of doing W1 is 3, number of ways of doing W2 is 3, number of ways of doing W3 is going to be 7 times 7 times 7, which is equal to 7 raised to 3. So number of ways of completing the task is equal to 3 times 3 times 7 raised to 3, which is equal to 3 squared times 7 raised to 3. So W1 is to fill the first blank with an vowel. And W2 is to fill the last blank with an vowel. So here the vowels are A, I and E. Next we have exercise 5b problems. Almost all the exercise 5b problems are easy. Maybe instead of saying easy, all the exercise problems in 5b are based on example problems. So those who are interested, they can skip the video and try the problems on your own. So if you cannot able to solve the problems, then you can come back here and you can look for the hints. Okay. Anyway, let me solve this problem for you. Find the number of 6-digit palindromes that can be formed using the digits. They have given 2 sets of digits. Okay. Now we have only one formula to find the number of palindromes. So the formula is like this: number of palindromes is equal to n raised to r upon 2 when r is an even number, and number of palindromes is going to be n raised to r plus 1 upon 2 when r is odd. And r is an even number, we have to use the first one. When r is an odd number, we have to use the second one. Here r is equal to 6, therefore we have to use the first one. Therefore number of palindromes is equal to n raised to 6 upon 2, which is equal to n raised to 3. Okay, so let us answer the first question. The given digits are, so the given digits are 0, 2, 4, 5 and 6. These are the given digits. and they are 5 in number. So total 5. So we have n is equal to 5 and r is equal to 6. Therefore the total number of palindromes is equal to 5 upon 6 by 2. Sorry, 5 raised to 6 upon 2. So which is equal to 5 cubed. But here we have this culprit 0. We have this culprit 0. So I cannot form a 6 letter word or 6 digit word starting with 0. We have to form a palindrome with 6 digits. 1, 2, 3, 4, 5, 6. So in a palindrome with 6 digits, it is sufficient to fill the first 3 blanks. Now here I cannot fill the first blank with 0. So first blank can be filled in only 4 ways. And the second blank I can fill in 5 ways, and the third blank I can fill in 5 ways. Therefore the total number of palindromes here is equal to 4 times 5 times 5. So this is the answer for the first question. And coming to the second one, so there are no restrictions on these blanks. So I can fill these 3 blanks in any of these 5 ways. Therefore here the answer is going to be 5 times 5 times 5, which is equal to 5 cube. So whenever 0 is there, you have to be little bit careful. You should not use the formula directly. Okay. So let us move on to the next question. The next question is like this. Find the number of bijections from a set A containing 7 elements onto itself. I don't know why they have asked this question in 5B. This question may have been asked in 5A itself. Anyway, first let us try to answer the question. So what do you mean by a bijection? By a bijection we mean it should be both 1 1 and onto. Okay. So instead of writing 7 letters, first let us try to understand this one using these examples. Suppose you have a set with 3 elements A, B, C. Now here also we have A, B, C. How many bijections are there from this set to this set? Now I can map A to B, B to C, and then C to A. So this is going to be a bijection. Bijection means it should be both 1 1 and onto. 1 1 means no 2 elements here should map to the same element. Onto means codomain should be equal to range. Okay. So A is mapped to B, B is mapped to C, and C is mapped to A. Basically by a bijection here we can say that we are rearranging the terms. I can rearrange ABC in 3 factorial ways. Therefore the total number of bijections here is going to be 3 factorial. If cardinality of A is equal to 3, if cardinality of A is equal to 3, then the total number of bijections is going to be 3 factorial. If cardinality of A is equal to 7, then the answer is going to be 7 factorial. Okay. So A has 7 elements. So let us write down those 7 elements. This is my A, A1, A2, and so on up to A7. And again we have this set A, which has A1, A2, and so on up to A7. A1 can be mapped to any of the 7 elements. Similarly, A2 can be mapped to any of the 6 remaining elements. A2 can be mapped to 6 elements. So on, A7 can be mapped to 1 element. See here A2 can be mapped to 6 elements means can be mapped to any of the 6 elements. So the number of ways of mapping A1 is 7, number of ways of mapping A2 is 6, number of ways of mapping A7 is going to be 1. Therefore, the total number of bijections is equal to 7p7, which is same as 7 factorial. So by a bijection we can roughly understand like this. We have to just rearrange the terms, or we have to just rearrange the elements. If you just rearrange the element, then it will give a bijection. So we have seen it here. So A is mapped to B, B is mapped to C, and C is mapped to A. So here we have this ABC, and here we have BCA. So this BCA is a rearrangement of ABC. So by a rearrangement we are going to get a bijection. So here also, instead of asking the question like this, number of bijections from a set A which contains 7 elements, we can just ask the question like this: how many rearrangements are possible with 7 elements? The number of rearrangements is equal to number of permutations, which is same as 7p7, which is equal to 7 factorial. So I encourage the students to write down the problem step by step. Okay, so let us move on to the third problem. Find the number of 5-digit numbers which are divisible by 5 that can be formed using the digits 0, 1, 2, 3, 4, 5 when repetitions are allowed. So we have to form 5-digit numbers using the digits 0, 1, 2, 3, 4, 5. And then we have to count how many of these 5-digit numbers are divisible by 5. So before going into the divisibility of 5, we have to recall what is the test of divisibility for 5. So a number is said to be divisible by 5 if the units place is either 0 or 5. So if I want to find, okay, let us move on to the solution. So 5-digit numbers divisible by 5. So 1, 2, 3, 4, 5. I have to fill these 5 blanks using the digits 0, 1, 2, 3, 4, 5. So the number of digits is equal to, given digits are 0, 1, 2, 3, 4, 5. So on the whole we have 6 digits. So the last digit I can fill with either 0 or 5. So the number of ways of filling this last digit is equal to 2 ways. I cannot fill the first blank with any of these 6 elements, because in these 6 elements we have 0. So if I fill the first blank with 0, it is not going to be a 5-digit number. Therefore I can fill the first blank in 4 ways. So the remaining blanks I can fill in 6 ways, 6 ways, and 6 ways. Therefore the total number of 5-digit numbers which are divisible by 5 is equal to, here I can fill it in 5 ways. So 5 times 6 times 6 times 6 times 2. So this is your answer. The number of 5-digit numbers that are formed using the digits 0, 1, 2, 3, 4, 5 which are divisible by 5 is equal to 5 times 6 times 6 times 6 times 2. Okay. Find the number of numbers less than 2000 that can be formed using the digits 1, 2, 3, 4. Okay, so we have done a few, similar kind of problem in 5A. In 5A, the problem is find the number of numbers greater than 4000. Here, the number of numbers less than 2000. So all 1-digit numbers are less than 2000. All 2-digit numbers are less than 2000, and all 3-digit numbers are less than 2000. But all 4-digit numbers are not less than 2000. Therefore, we have to all 4-digit numbers which begin with 1. All 4-digit numbers which begin with 1 are going to be less than 2000. Therefore, the total number of numbers which are less than 2000 is going to be number of one digit numbers, number of two digit numbers, plus number of three digit numbers, plus number of four digit numbers which begin with 1. So I hope you can answer these questions. Number of one digit numbers is just going to be 4, either 1, 2 or 3 or 4. Number of two digit numbers means we have to fill these two blanks with any of the 4 digits. Number of 4 digit numbers is going to be 4 square. Number of 2 digit numbers is going to be 4 square, and number of 3 digit numbers is going to be 4 cube. Okay, let us move on to the next question. Find the number of 4 digit numbers that can be formed using the digits 0, 2, 5, 7, 8, which are divisible by 2, which are divisible by 4 when repetitions are allowed. Anyway, I am not going to answer this question which are divisible by 2. So I think you can answer this question. I am going to answer the question which are the question that is all 4 digit numbers which are divisible by 4. All 4 digit numbers that are formed using the given digits which are divisible by 4. So first let us write down what are the given digits. The given digits are 0, 2, 5, 7, 8. So we have to form 4 digit numbers. So 4 digit numbers means we have to fill these 4 blanks. So what is the test of divisibility for 4? The test of divisibility for 4 is the last two numbers should be divisible by 4. If the last two numbers are divisible by 4, then we can say that the number is divisible by 4. So let us see in how many ways we can fill these last two blanks. So I can fill the last two blanks with the first option that I have is I can fill the last two blanks with 0, 0. And the second option that I have is I can fill the last two blanks with 0, 8. And the third option we have is I cannot 2, 0. And the fourth option that I have is 2, 8. And the fifth option that I have is I don't have any number which starts with 3 which starts with 4, so I have to search in 50s, so 52. And the sixth number is going to be 52, and then okay, I don't have any numbers with 5 and 6, and then we have 72, and we have 80 and 88. So I can fill the last two blanks with any of these 8 options. I can fill the last two blanks with any of these 8 options. Okay, in how many ways I can fill the first blank? So here I cannot fill the first blank with 0. So I have only 4 ways to fill the first blank. And then I can fill the second blank in 5 ways. And then I can fill the last two blanks in 8 ways. Therefore, the total number of 4 digit numbers which are divisible by 4 formed using these digits is equal to 4 times 5 times 8. These are the total number of 4 digit numbers which are divisible by 4. Next we have this problem. Find the number of 4 digit numbers that can be formed using the digits 0, 1, 2, 3, 4, 5 which are divisible by 6. I repeat, find the number of 4 digit numbers that are formed using the digits 0, 1, 2, 3, 4, 5 which are divisible by 6 when repetitions are allowed. So what is the test of divisibility for 6? Test of divisibility for 6 is the number should be divisible by 2 and the number should be divisible by 3. So when do you say that the number is divisible by 2? If the units place is even, or if the number is even, we say that the number is divisible by 2. When do you say that the number is divisible by 3? The sum of the digits must be divisible by 3. But here we don't know what is the sum of the digits because we are repeating the numbers. So we have done an example problem related to this one. So this question is also based on that example problem. We have to form a 4-digit number. 1, 2, 3, 4. So which is divisible by 6. So let us try to observe the given numbers. The given numbers are 0, 1, 2, 3, 4, 5. They have given 6 digits. And if you observe, all these 6 digits are consecutive. So first let us fill the first 3 blanks. I can fill the first 3 blanks in 3 way. With XYZ. After that I can fill the next blank with either 0, 1, 2, 3, 4 or 5. Now I have these 6 consecutive numbers. Out of any 6 consecutive numbers, there is only one number which is divisible by 6. Out of any 8 consecutive numbers, there is only one number which is divisible by 8. So if I write any 2 consecutive numbers, there is only one number which is divisible by 2. If I write any 3 consecutive numbers, there is only one number which is divisible by 3. If I write any consecutive 6, if I write any 6 consecutive numbers, there is only one number which is divisible by 6. So I can fill the last blank with only one of these options. So first let us see in how many ways I can fill the first 3 blanks. So I can fill the first blank in only 5 ways because we have 0. I cannot fill the first blank in with 0. Now I can fill the second blank in 6 ways. I can fill the third blank in 6 ways. But I can fill the fourth blank in only one way. Why I can fill the fourth blank in only one way? Because out of these 6 consecutive numbers, there is only one number which is divisible by 6. So let me write the statement for you. Out of any 6 consecutive numbers, there is only one number which is divisible by 6. Therefore, total number of 4-digit numbers which are divisible by 6 is equal to, answer is 5 times 6 times 6 times 1. Why we have this 5 is, I can fill the first blank in 5 ways, I can fill the second blank in 6 ways, I can fill the third blank in 6 ways, but I can fill the fourth blank in only one way. Therefore, the total number of 4-digit numbers that are formed using the digits 0, 1, 2, 3, 4, 5, which are divisible by 6 is going to be 5 times 6 times 6 times 1. So with this we have finished all the exercise problems in 5B. So whatever problems that I have left are easy, so you have to try those problems.